Good morning. This lesson is for my Integrated 1 class. This is for Unit 2, Lesson 1. But before I get started, I want to say that I hope everybody's doing okay out there. So let's just go ahead and jump into our goals. We have 3 goals today. Our first goal is we're going to review inequality symbols and translate their meaning. Our second goal is we're going to graph inequalities. And our third goal is we're going to write inequalities that represent graphs. The first goal, when I was in school, I had a hard time understanding inequalities, and when I first started teaching, my students struggled with how I taught inequalities because I taught it how I was taught, and so I left that style of teaching behind, and I tried to come up with another way to talk about inequalities and look at them in a simpler way. And so I realized that inequalities really only describe position. So if we understand that inequalities are ways to describe position, I think we're going to be in a much better place when it comes to inequalities. So let's make sure that we write this down. And again, if I write it, you write it, and we think about it like this, it's going to be a lot easier for us to write inequalities, graph inequalities, interpret inequalities. So let's go ahead and just jump right in here. So this symbol, is less than. I remember that it's less than because I can make an L out of that symbol. So that's what I use to remember what it is. It's called associative memory. It's a little trick you can use to help memorize things. But I don't look at this as less than. To me, this means left of. And again, remember, I look at inequalities as describing position. So I'm using this as a way to describe who's left of somebody else. I don't call this less than or equal. I call this left of or at. So if this symbol is left of, then we can conclude that this symbol must be right of. And we will call this symbol right of, this symbol, not this is the phrase, this symbol right of or at. And I don't call x my variable, I call that my shading. And it's very important that we understand that the shading, that is where our solution is. So the shading is the solution. So we understand that the shading is the solution. And that's going to help us to understand the difference between right of or at versus right of or left of or at versus just left of. So I'll get into that here in a little bit. But again, I like to translate their meaning into something different. And so I'd like to give an example right now of how I would explain this. And I probably need to erase this so I have more space. But again, just to remind you guys, I use inequality symbols to describe position. Okay. So I can describe the position of 5 relative to 6 as 5 is left of 6, right? I probably should have used the symbol. That would hit home a little bit more. 5 is left of home. If I write it mathematically, I would write it like this. 5 is left of 6. Not 5 is left of home. If I was to write it more mathematically, I would write it like this. 5 is left of 6. So this is how I describe the position using 5 as my beginning concept. If I talk about position using 6, I would say that 6 is right of 5. Or if I wanted to make it a mathematical statement, I would say that 6 is right. That's left, not right. Let's learn the directions here. We'd say 6 is right of 5. So this is a way that I'm going to understand. Now, if less than and greater than is something that you like to use it. This is just a suggestion for those of us who struggle with inequalities. And again, like I said, I struggle with them. So please use whatever helps you. This is a suggestion. And again, inequality symbols really just describe location. So I'm going to check off the first goal here, And I'm going to move on to the second goal. And our second goal is to graph inequalities. Okay, so I would like to just create 4 inequalities that I like to graph. And again, I'm going to use this translation to graph them. And hopefully I can answer some questions about the difference between less than versus less than or equal to, or left of versus left of or at. And the same thing for right of and right of or at. Okay, so I'm going to write 4 inequalities here. And so let's get into our second goal. Our second goal and again is to graph inequalities. So I'm going to write 4 inequalities to graph. Okay, so again, I'm going to translate it using these concepts. To me, this is saying that the shading, which is the solution, the shading is left of 4. Okay, so what I'm going to do to graph this is I'm going to put a 4 here. I'm going to put an open circle, and I'm going to shade to the left. Okay, because again, this is saying that the shading is left of 4. I didn't shade in this circle. I'm going to graph this one and I'm going to explain the difference here. So this is saying again the shading is left of or at 4. The shading is left of or at 4. So I'm going to put 4, I'm going to draw a circle. This time I'm going to shade inside the circle, and now I'm going to shade to the left. And I want to talk about the difference between an open circle and a closed circle. And remember, the shading is a solution. And so if I was to put this value here and I translate it, is 4 left of 4? 4 is not left of 4. That's false. So this cannot be a solution to this. And since it can't be a solution, it can't be shaded in. All right, let's look at this one. This is shaded in. And so what this is saying is 4 is left of or at 4. Well, it's not left of, but it's at 4. And so since that's true, it's a solution, and I'm going to shade that in. So you can also think of these as boundaries. When I don't have a line, the starting value is out of bounds. When I do have a line, the starting value is in bounds and is part of the solution. And I'll keep stressing this over and over and over again to help you guys understand the difference. And it's going to take a little practice, but again, 4 is not left of 4, that's why it's not shading, because it's not a solution. 4 is not left of 4, but it's at 4, right? Because it's at 4. So it is a solution, and that's why I shaded in. It's that little equal sign under there that allows me to shade that in. This translates to the shading is right of 5, and just like before, 5 is not right of 5, so I can't shade in at 5. So I'm going to leave that open. All right, and just like above, I'm going to shade at 5 because the shading is right of or at 5. So I'm going to shade that one in, and this would be an example of our 4 types of graphs that we would have in inequalities. So I would shade that in. Let me, I want to look real quick just to see how much space I have on the whiteboard, because I do want to talk about one thing really quick. Okay. So we know how to graph when we start with the shading. What happens if I ask you to graph something that looks like this? -6 is right of or at the shading. I'm going to tell you that I have a hard time graphing this. And so what I recommend is rewrite this. So we start with the shading, and I'm just, we start with the x. So if -6 is right of the shading, and I rewrite this, I would say that the shading is left of or at -6. always start with the shading. And again, I find it a lot easier to graph this. So -6, and there's my shading, and I shade to the left. But this graph also matches this. -6 is right over at the shading. -6 is on the right of the shading. So in this graph or this inequality is represented by the graph. It's a little harder to interpret. So I'm going to check off my second goal. My second goal is done. And let's move on to the third goal. Our third goal here is to write inequalities that represent graphs. So it's actually a kind of simple thing to do if we think about just describing what we see, describing position. Okay? So let me go ahead and erase this. And again, for notes, if I write it, you write it. So when I'm grading your notes, I don't want to see just stuff written out. I want to see graphs. That's what the goals were about. You know, this is your book that you're creating for this class. So the better notes you take, the better off you're going to be. So our third goal again. Our third goal is going to write inequalities that represent graphs. So I'm just going to do a couple examples. And actually, I'd like to write 2 inequalities for each graph. Okay, so let's just do an example. It's not going to be too difficult. All right. So if I look at this picture of this graph, to me, I would say that the shading is right of 7 or at 7. So I would write my inequality. The shading is right of or at 7. Okay, that's one inequality that describes this graph. Or if I want to start an inequality where I start with 7, I would say that 7 is on the left of the shading or at, how does it? 7 is left of or at the shading. Is that right? 7 is left of or at the shading. I guess it's a little quirkier when we start with this. But again, understand that that 7 is part of the solution. So 7 is left of the shading, or 7 is or this. How do I say this? Now I'm a little bit tricked, a little stumbling here. I got to think about this. So maybe one of you guys will help me with a better way to describe this. 7 is left of the shading, but it also starts at 7, I guess. I don't know. I've never actually had to explain this one before. This is the issue when you try and put things in your own words. You're going to come across these little hiccups, and we have to figure that out. But again, this goes back to all about just describing what we see. Okay. So I'm going to say that I did hit my third goal of writing inequalities that represent graphs. So let me check that off and just review what we did. Inequalities symbols, I translated them. They're just describing position. Graphing inequalities, you're just drawing what you're going to translate. And when you're writing an inequality that represents a graph, you're just explaining what you see. Right? The shading is right of the 7, or starts at 7, or 7 is left of the shading and also includes 7. So this is, like I said, I think it's pretty simple. It helped me a lot to think about this as just describing location. So that's going to be it for the lesson. Again, I hope everyone is doing okay out there. Have a good day, everybody. Bye-bye.